Alrighty, and welcome everyone to the Retrotec duct testing demo webinar. Here you can see we've got a duct tester and everything set up here that we'll get to here in a minute, but I just kind of wanted to give you a little history to start off with. This is a photo we came across not too long ago that kind of shows some of the manometers of Retrotec's past here. So that very first picture that you see for 1989, that is the first residential duct tester ever, invented by Colin Genge in 1989 for the Canadian government. Kind of similar principles to the ones that we use today. It uses the centrifugal blower. And then as duct testing demand picked up, then that's when we really got serious with manufacturing the ones that kind of led up to the one that we have today. But you can kind of see manometers have come a long way over the years since then. They used to pack up in a hard suitcase and had the old Dwyer magnehelic gauges on there. And then Ben Walker came out with our first digital manometer there in 1998. And Ben's one of our co-CEOs now. And of course now, currently we have the DM32, which launched, this says 2013. I think we sold our first one in 2012 though. So she's 9 years old this year, just about. So, but still running strong. It was the first wireless touchscreen. But we'll go ahead and dive into this now. I'm gonna stop sharing. And let's see if we can highlight, or let's see, spotlight my screen. There we go. What we're going to do, we're going to start off with a leakage to the outside test. We'll run one manually, and then we'll run one with our automated testing app, rCloud. And then what we'll do is we'll stop after that. We'll take questions, and then we'll pivot over to my air tightness chamber that I've built, where we'll do a duct leakage to the outside test. So as we're going through, if you have any questions, go ahead and send those into the chat box. The ones that Lee can answer as we go. Lee's online with us too. Lee's from our tech support department. So he can answer stuff as we go. And then ones that will need a more verbal answer for everyone, we'll stop halfway through and stop again at the end. So we will go ahead and dive in here. So as you open up a duct tester kit, out of the case that it comes in, as you see here, some of these on the shelf, we have the Calibrated Fan. So this is the model 300X that we came out with about a year or so ago. And it's a more robust fan shell, has a wider stance. So if you need to set it up on a platform, it's less chance of tipping over. We put a magnetic plate here too, so that you can actually attach the gauge to the fan shell. That way you don't have to leave it on the floor for either yourself or somebody else to step on and ruin the gauge. So it's just a feature that we wanted to add there to help your tools last longer. And then of course we have the flex here that the fan attaches to. We have what's called the quick connect collar. So as you change fan direction, there's no need to take anything apart. It literally just snaps on both sides the same way. And then on the other end here, we have our flange. And this is a flange that's unique to Retrotec. It'll work on other residential duct testers though, as they both use the same size flex to hook up to the system. And it's clear plastic that has two adjustable hooks on here that you can hook up to the return. But before we get started, there's this is a Mitsubishi ducted mini split system. Big thanks to Mitsubishi for donating this to the test lab here. It's been awesome and great for low load houses, and it works just like a regular split system. We're going to test it the exact same way. It's just just kind of a smaller version of everything. So the first thing we will want to do is turn that thermostat off. The last thing we want to have fan kick on as we have everything taped up. That includes ventilation controls as well. Anything that's going to manipulate pressure inside of that duct system, we want to make sure that that's not going to kick on. So If it has a fan cycler switch that's, runs ventilation a certain number of hours a day, we want to make sure that's not going to come on during the test. If there's a ventilating dehumidifier or something like that hooked up to the duct system, we want to make sure that's not going to turn on as well. So we want nothing going on inside of that duct. The only thing we want to see moving is air generated by the duct tester fan here. So I've already done that. Thermostat's off. And another thing that we want to do too is open up a door to the outside, a door or a window. And the reason that we want to do that, a lot of test standards require this. And the reason for doing so is, say we have ductwork on the outside of the envelope. I'm actually going to shut this door for the purposes of this demo. We're about to get some wild weather come through here. I'm in Wilmington, North Carolina. Lee's in Myrtle Beach. He said it's already started blowing pretty hard down there. But fingers crossed we keep power the whole time. But as we hook up this duct tester to the system and get it running, say we're going to depressurize the ducts, and we're going to be pulling air through the leaks of the duct system. And if we're pulling air envelope, we can pressurize the house a little bit that way, and the manometer is going to pick that up, and our reading is going to be a little funky. So that's why we want to have a door or a window open to balance that out, to prevent that house from pressurizing. So, and once we do that, we want to make sure that we take the filter out. So on these mini split systems here, there's a filter slot here. These come with a little reusable filter. It's about time for this one to get a bath. And we'll just set that aside. A lot of the split systems that you guys will test will have, the disposable filters in there, or maybe one of the big media filters. And then we'll just put this filter access panel back on like so. Once it decides to cooperate with me. There we go. Now we're all set up. We've got the filter out. We've got the door window open. We're made sure that it's not going to kick on. All the controls are off. So now we can go ahead and start hooking the system up to the ductwork here. So usually what we're going to do is return, like you see like here. A lot of times it'll be a main return. That's where this type of flange here comes in handy. It's got these two hooks on it. So if you're hooking up to a return in the ceiling, you can just hook it on. That way you're not having to try and hold it up with one hand and try to tape around it with another. So we'll go ahead and hook this on like so. There are some cases where you may want to attach this to the air handler itself. Say you don't have a good return access, you can do that too. What some folks do, they'll take the service panel off and then either come up with a way to, come up with your own panel out of cardboard or plastic or something like that, or you can just tape the flange in there and just make sure you have a good seal. So those are the two most common ways that we're going to attach this duct tester to the duct system. And the next step that we're going to do, we want to make sure we have around this thing. So we have our grill mask here. A roll of this does come with your duct tester kit. And we sell more of it as well. And this is good stuff. You can kind of think of this kind of like a saran wrap on steroids. It's strong enough to stay on there during the test, but it really shouldn't take off paint. Though we have seen that happen before, especially in new construction where that paint job is still kind of fresh. Sometimes it can take off a little bit there, so it's important to be careful there. Go ahead, get this one on. And you want to make sure that you are sealing. Let's say this return was in the ceiling or in a wall. You want to seal it to that drywall or that wall paneling, whatever ceiling paneling it's on. That way you're sealing that return there, because that crack between the return grill And that drywall is going to count as leakage. And this stuff does like to stick. Usually, if you get this balled up like that, you can pull it apart. Not all tapes are like that, but this one is. So it's a little more cooperative than other stuff out there. So now we have our flex here attached to the return. So let's talk about the fan setup here. You can test in either direction you want. You can do a pressurization test like we're set up here. There's a handy arrow on the other side here that shows you which way the airflow is going to go. The side where you would adjust the hole size opening is always going to be the inlet side. So air is going to come in through this way and out the other. The leakier the duct system is, the more open you're going to want to have this. So the gauge telling us if we're on that right range or not, and we'll get to that in a second. But the way you change these is that's fully open. This plate is magnetic. It just sticks on like so. The next range is just having that plate open. And then this is range 74. There's a little 74 sticker on there. That 74 just means it's 74 millimeters across in diameter. And that just pops in like so. And like I said, we can test in whatever direction we want. We can pressurize it, which means putting it on like that. Our quick connect collar snaps on there. Or we can flip the fan around and depressurize the duct system. And this is what I prefer to do. I always prefer to depressurize the system for the main reason of, as we have our supplies and our returns taped off, it's going to pull that tape tighter to the register rather than blow it off. And when that happens, it can be a little frustrating because then you have to go walk around the house and figure out what came loose. So there's less chances of that happening when you run a depressurization test. So we will run it. Now that our fan's connected, the next step that we want to do is connect the gauge. So I have this manometer connected to this iPad so that you guys can see what's going on. This app is called Gauge Remote, and it's available on Apple and Android, and it's free. You just download it, and you can either connect the device to the Wi-Fi signal or the Wi-Fi antenna on the gauge, or the other way around. Right now I have the gauge connected to the iPad. We found that actually gives you a more stable connection doing it that way. So that's called Wi-Fi Create or Wi-Fi Join. We're using Wi-Fi Join. I'll come up a little closer to you so you can see this next part. And it's really easy. This is a feature that's unique to Retrotec, and it's our color coding system. You know, there's this, it's what's called the umbilical that has the different tubing on there and the data cable. The data cable will plug in to the top of the gauge. And as you can guess, the green tube goes to the green port. The yellow tube goes to the yellow port. And this is on the channel B side of the manometer. So these two are reading fan pressure coming from the fan. And then we have this blue one that, you guessed it, goes to the blue port. And this side is going to go to the duct system. We have to have something in there measuring the duct pressure. That way we know when we get to that 25 Pascal target, or negative 25 in this case, we're going to depressurize. So that's how the manometer knows once we've gotten to that target pressure. And then we're going to do the exact same thing on the fan side. Slap the manometer back there. As I mentioned before, yellow and green read fan pressure. So there's a matching yellow and green port on here. So we will pop those on there like so. And then the other end of that data cable plugs into the fan as well. This allows the gauge to control the fan. And last but definitely not least is power. We want to make sure we plug it in. There's a power switch, turn the fan on. And we should be Good to go. There's a little status light that comes on here. When it's green and steady like that, that means that it is reading a signal from the gauge. So that's a good sign. If you have everything plugged up correctly and it's blinking or turning red, that usually means your data cable has gone bad and it just needs to be replaced. So that's something to look out for if you're a really heavy user of this equipment. Just a way to troubleshoot some things if something weird happens in the field. The last thing that we want to do now is get the rest of the system taped up. And to save time, I've already done that for the most part. Our supply is overhead here. So what I'm going to do is angle you guys up and show you how to attach that blue port or the blue tube on there to read duct pressure. And there's a way that I like to do this that I've found to be, the most reliable and easiest over the years. It's an extra thing that I like to keep in my tool bag, and that's painter's tape. And it does come in handy. So give me just a second here to get this squared away. There we go. So the thing that we're going to put on the end of this blue port is a static pressure probe. And we're just going to slide that probe into that supply. And we usually want to do this on the supply closest to the air handler, just like we have here. So the first thing I'm going to do is just tape that supply up just like I would the rest. Get that so it's going to cooperate. Using this same duct mask tape, grill mask, whatever you want to call it. Peel it off, get the right amount you need. We have 3 sizes of this available. So if you work with a lot of houses that have multiple returns, we have larger sizes of tape. That way you don't have to spend time using these skinnier pieces. But these 8-inch rolls are really nice for these types of supplies here. And we want to make sure that, once again, we want to tape that register all the way to the wall or the ceiling, whatever it's attached to. Now, the next thing we want to do, there's some perforated edges there. And so we just want to poke a hole there with our finger. And then take this static pressure probe and pop it in like so. And if you notice, some of them have a magnet that can kind of help hang it on. Sometimes it's not enough. But, we've made a hole there in the system. So what we want to do is grab some painter's tape and just give it a little extra support. So just a little piece on one side to hold that on. So you're holding that static pressure probe there in place, and you're sealing up that hole at the same time. And there we go. I have done this before where it has fallen out, and I've run the fan and tried to figure out why I'm not getting the pressure. If you don't have anything in the duct system to read pressure, then the rest of it's not going to cooperate. So you want to make sure you have a good secure connection there. So now we're ready to run. We have everything installed. All of our tubing is hooked up. Our data cable is hooked up. Might be nice if I get you guys pointed back over so you can see. Let's get that iPad in there so you can see what's going on. Right on. So there's a couple of ways that you can do this. Like I mentioned before, the gauge can be the control. There's a manual dial here on the fan, but if I'm just doing a total a total duct leakage test where I'm testing the whole system. I'm just going to let the gauge do the work for me. So there's a few things that I want to make sure I'm have set up correctly in the gauge. There's different outputs that we can have. So if you're not familiar with the DM32 gauge, let me run through this right quick. Channel A is on top here that you can see on the iPad now. That has 2 zeros. Under that, where there's 2 dashes, is channel B. And channel A is reading our duct pressure. Channel B is reading our fan pressure. And this does the math for us to give us the flow. And the way we want to interpret our results is, sometimes we'll have a target that we want to shoot for. Say we're testing for code. A lot of times that target is represented as a percentage of the floor area that the system serves. So, say we have a 1,000 square foot home. If our target is 6%, then we want to be at or under 60 CFM. So that's a way to look at that. And there's different ways you can have that represented on the gauge. So we want to have channel A represent pascals for us. So we have that. If we want to change channel B, we can just tap on it. And then, we have flow at CFM, our metric, but CFM is what we want. We can have flow per area. So if we want to do that, flow per 1,000 or per 100, because I like to use that when I'm testing ducts because it gives us that percentage that we want to output in a report. So we'll use that. And anytime that I want to go back to the home screen, I can just tap the power button. And now we see on the gauge here, you can see below the picture of the fan, there's area and 1,000 square feet. If I want to change that, I can just tap area and enter that in. But for this, example, we'll keep it at 1,000. So we'll hit cancel. Now we're ready to, aside from, the fan setup, again, this is a 340X fan. So we want to make sure we have the right fan selected. And to do that is you picture of it. And if you have the wrong device selected, you just hit change device and it has all of our duct testers there. All competitors' fans are in there too. All of our blower doors are in there. So one thing to pay attention to is there's a 300 option that has this picture of the fan. That's if you're going to use this fan as a blower door. So you want to cycle through and choose the 340 option, the picture that has the duct coming off of the side of it. And so we're going to choose that. And then, yeah.
The screen you have up isn't updating to show those menus. Do you want to hold the gauge close to the camera for a second and show how you did that?
Yeah, sorry about that. Well, I guess we can do it here. How about that?
Oh, that works.
Boom. Yeah, I'll run through that again. So changing the device, there's all the devices you can choose. So you just want to make sure you choose the right one. So this is the 340X. The 340 is what we're going to choose. These other ones are older models or commercial models. So we're doing a residential duct test. So we're going to choose that. And then we have our range that we want to select. So if we're going to run it open at the 102, 74 is usually where I like to start. If it's a reasonably tight system, 74 will do it on a small to medium sized house. And we just want to make sure that that's going to be represented in the fan as well. So if you have 74 selected in the gauge, make sure you have 74 installed on the fan. So now we're ready to go. The way we're going to run this is, we test every system to 25 pascals. Let's get this on 74. There we go. We'll go to set pressure, 25, hit set. And I'm not sure if you can hear the fan kick on, but it is running. As you can see, we're getting our duct system down to pressure. It's seeking that negative 25. We're at about negative 20 now. And notice on the bottom, we have that FM per 100 square feet selected. So that's going to give us that percentage that we're looking for. So we're already past our target. If 6% duct leakage was what we wanted, held that. And I say 6% because that's, if you're looking at a lot of different state codes or regional codes, 6% is a pretty common number. Some would go down as 4. I think Virginia just adopted 4% total leakage this year. Some more rigorous building performance standards go down to 3. That's the one that I used to manage when I was at Advanced Energy in Raleigh, North Carolina. We always required 3% total. And really, to get those tight ducts like that, bucket mastic is the key. John Tooley was the lead building scientist there for years. And one thing he always said was that bucket mastic needs to be as thick as a nickel. And you just want to apply that to every connection that's within the duct system. And that's how you get a really tight number like that. But when we had this system installed, I left some leakage there on purpose. So that way I can show you how to identify where some of those leaks are located with some other tools that work along with the duct tester. So it looks like we've gotten it down to pressure. We're at 25. And it looks like we have about, 6.5% leakage there. And if we wanted to go back and just see what that total CFM is, we can just tap on channel B and just have the flow output to CFM, go back. And yeah, 65 CFM would be our total. So there's different ways you can have that displayed. And that's how you get your duct leakage number. Pretty easy. We try to make it as easy as we can. Everything's color coded. There's nothing extra that you need to do to switch it from pressurization to depressurization. I'm going to go ahead and stop the fan here. And just to show you, if I did want to pressurize it, there's other models out there where you have to set the gauge up differently. And there's extra tubing you would need to add on. There's extra parts that you would need to add in, like a flow straightener or something like that. This one doesn't require any of that. It's very straightforward. You literally just pop the flange off, flip the fan around, pop that flange back on, and then carry on. That's literally all it takes to go from pressurization to depressurization. So what we'll do now, that's how you run one manually. If we want to use software, what we have now is the rCloud app. And that's how you run either a duct test or a blower door test and have it auto. You can set your parameters inside the app. Like, if we wanted to use that 6% number again, I can put that in there. And then right at the top of the report, it'll tell me if I passed or failed.
Hey, Sam,
so, yeah.
You want to take a second? And it looks like we have quite a few questions here.
Sure, yeah.
Yeah, so first one would be, does the static pressure probe need to point a specific direction?
It doesn't really make all that much of a difference. Usually you want to get it pointed into the airflow. We've run tests before with without the static pressure probe and just having the raw air, and there's really not a whole lot of difference. But usually, there's a point at the end of that static pressure probe, and usually you want that kind of facing into the airstream. But what I've seen over the years, it doesn't really affect the reading all that much.
Yeah, the static pressure probe, the goal of that is to cut down on velocity pressure. You don't want velocity blowing to the end of the tube, so that is read as pressure. And at a register, the air is pretty much dead-ended anyway. You're not really going to have much of a problem. It's not like putting a static pressure probe in the air handler, right after the blower, where that would be important. In this case, it's pretty doesn't really matter much. And
another thing to keep in mind too is we're putting a 25 Pascal pressure on the duct system. Most duct systems, if you have a single stage system, an ideal operating static pressure is 0.5 inches of water, which is about 125 pascals. So it's a lot less pressure than the system experiences when it's running. So.
Yeah. The other question was, what would you do if you have an air intake on the outside, like a fresh air inlet?
Yeah, so depending on what standards you are testing to, depending on how that runs, if it's just wide open without a damper, and if it's running continuously, you can tape it off. That's for ResNet. But a lot of the times it'll just have a powered damper. Those are the ones that I prefer. They usually have a pretty good seal on them. And you can just leave those as is. But yeah, it's important to look up what your test standard requires. If you're testing to ResNet, they have some different requirements that they tell you to do. A lot of times, they'll tell you to kind of leave it in its natural state. Power dampers are always going to be closed if they're not running. And you want to look at and see how often that ventilation is running to determine that.
Yeah. Okay. What about, you mentioned this already, but just to go over it one more time, a connection to the outside. Does a window or a door need to be open? And why would that be?
Yeah, so we do want to open a door or a window to the outside. And yeah, I mentioned this towards the beginning. Let's say we have a duct system where all or part of it is on the outside of the envelope. As we're running our duct tester, we're going to pull in leakage from the outside through pull in air from the outside through that leakage, and we can pressurize the house that way. And the manometer will pick that up, and it will throw off our reading and make it less accurate. So we want to prevent that from happening by either opening a door or a window. If the house is still at the rough end stage, a lot of times it's, you're fine, unless it's, the air barrier is already fully installed. But for existing homes or finished homes, yeah, you definitely want to do that.
Okay. It's very similar to like an attached volume, if anyone does blower door testing and has run into that before. Let me see. How about several people are asking about the gauge that we're using, that transparent gauge, if those are for sale.
Unfortunately, I don't think we have any more left. But reach out to the sales team. We might have some, I'm not sure, but sales@retrotec.com. Feel free to shoot them an email and ask. And there's really nothing else, going on with them. We just kind of made them for fun. We made some that light up different colors. So yeah.
All right, and then one last question here. Someone was asking if there's a different setting between the 340 and the 300. So if you're doing a duct test versus a blower door, there is. I think when we're showing the gauge again, maybe we can show that really quick. But there are two different device pages, one for blower door, one for duct tester, and they both have the 300 series on them. And the duct tester is always going to be the 340 or the 350. The blower door will always be the 300. Just that, like a package name we use for those two kits.
Yeah, if I go back in here, let's see here. If I go to devices, notice that we have everything grouped together. So Retrotec blower doors. So this 300 is the same fan, but it's using that fan as a blower door. And then we have our duct testers grouped together. Whoop. We have our duct testers grouped together here. Whoop, I keep hitting change device. Yeah, and so it's that same fan, but it has that flex coming off the side of it. So if you're doing a duct test, choose that one, and then whatever range that you have it set to.
Awesome. Okay, I think that is it for questions. There's a couple more, but I can answer them individually.
Okay. Cool. So I'm trying to get this iPad here to where it's going to give you a clear reading. The cool thing about this app is it geolocates where you are. So it puts a map on the report for you to prove that you were there. I think once I get into it, it'll clear up a little bit. So once you open up rCloud, if you've done some tests already, this is what it looks like. And if you want to add a new test, you just hit this plus sign. And we want to run a duct test. We can do a number of different standards here. We have, ResNet Chapter 8, the old standard. And then the newer ResNet 380, we have that in there too. The difference is, for ResNet 380, we actually have the standards in there. So you actually have to go through a checklist and verify that, yes, I did set up the ventilation, or I left the ventilation open if it was supposed to be, or I taped it off if it was supposed to be taped off. I opened a door or I opened a window, made sure the thermostat was off, things like that. So and do that one. Blower or duct tests are always going to be single point. And basically what you do is you just go through the motions. So here we're going to depressurize the system. And this next step is one thing that's been confusing a lot of users lately. I know the screen looks blurry here to you guys, but try to get it to where you can read. Okay, so this gauge location, you have the option of saying outside or inside. This does not mean inside or outside of the house. And I know this is going to sound a little wacky, but the software has to have this input. What this means is the gauge inside or outside of the duct system? That's always going to be outside of the duct system. We don't test with the gauge inside. You really can't do that. The reason we have to have this in is for the app to be able to allow the test to go in either direction. And it has to use the same language as blower door testing. And so for blower door tests, there are times where we have the gauge, outside of the envelope. So you just have to think about it that way. The gauge is outside of the volume of space that I'm testing. We know that's a little confusing. We get some updates here in the next few months. That's one thing that we're just going to have automatically populated and then hidden so you don't have to deal with it. If you choose inside and you start running your test, it's going to say, hey, your fan's in the wrong direction. So that's what that means. That is going to get cleared up in an update. But for now, for this option, choose outside. So we have that. This is where you can choose. This next option here is where you can choose your leakage percentage. So I want it, less than or equal to CFM per 100 square feet. I will put, we'll use our 6 again. And the area served by the system is, we'll use the same parameters we did for our manual test, and we'll say 1,000. And then we can hit next. Let's go ahead and get our location here. It found it right here on the map. I know that's not super clear for you guys. So we'll go ahead and hit save. Save and next are down here at the bottom. And you'll notice there's, it goes from exclamation point to check mark. Once you finish a task, that'll have that check mark there. If it doesn't have the check mark, you need to go back in and add some more information that it wants. We can verify the address here. It already has our name, but we can just put in the number, street number there. And if that's all we need, we can hit save. Whoop, verify the address. There it is, save. It just wants some information about the building. Again, it geolocates where we are. So I'm in Wilmington, North Carolina on the coast. So we're only 23 feet above sea level. The floor area, we're going to back that up and say that it's 1,000 to match what we put in before. And that's another thing too. So if the house has multiple systems, you're not going to put the house square footage. You're going to put the square footage that that system is serving. So if it's a 2,000 square foot house, hopefully it doesn't have 2 systems. Usually it doesn't need it, but it happens. If 1,000 is dedicated to one, then you put in 1,000 for the area that that system serves. So we'll hit save. Next is our weather conditions. It pulls all that outdoor weather data for us. So all it wants now is our indoor temp, and we'll put that in and hit save. We've got all 4 check marks there, so we can go forward. This is where the ResNet 380 related questions come in if you're doing a ResNet test. And so just to mark these off, it's just saying, yeah, I've turned the HVAC controls off. Yeah, if the ducts are going through an unconditioned space volume, I'm going to open up a door or a window, just like I talked about before. I can just put, for this one, there's just one return, so I can just put return pressure probe location, I can just say first supply. I'll just put first sub to save time and hit next. So now it's just finding the gauge through that Wi-Fi signal, getting connected to it. It also has all my fans saved in here too. So all the calibration data from each fan as it came out of the Retrotec lab is saved in here. So it's got the right fan that I want to use. It's got the serial number for my gauge here, and all my equipment's set up. And so I can go ahead and start this test. So it's just getting some things squared away here, getting the gauge zeroed out. It wants to run this gauge to a time average of 5 seconds. Once it has it all set up and I'm ready to go, I can just hit start. Now our fan is kicked on, and we can watch our pressure drop down to -25. I think you can kind of see that. It might look a little blurry. For some reason, this iPad's just not wanting to show up on camera today. But now we're getting some readings here. So it's going to take a number of readings and then average them together. So it's got everything there. Of course, we failed. We know that before. If this all looks good and we want to accept that, we can hit accept. And then there's our report. So it's got a big red fail there at the top. This is a leaky duct system. It didn't meet the code that we gave it to. And there we go. It has every aspect about the test in here that a ResNet HERS provider would want to see, or a code official would want to see. Submit it, which means, hey, if I hit submit, I can name it, whatever I want, and hit save, and then email it to myself, or email it to a code official, or email it back to the office, my provider, whatever I want to do. So that's kind of the quick and dirty on running a duct test on our cloud. And if we were to run a blower door test, we would go through the same motions there. It hooks up to the same DM32 gauge and runs the test the exact same way. So I don't have my email account set up on this, so I think that's what it's looking for. But if I were to use my phone where I had my Outlook app on there, it would pull that up and allow me to send it out that way. So any questions on our cloud?
It doesn't look like it, although it may be, and I might have missed, you may have already said this, but where would you go online to find these tests after you upload them?
Yeah, so if you're not going through the app, like I showed before, let's see here. Yeah, if you open up the app for the first time, you can see all your tests that you've done in here. But we also have a portal that you can log into. Once you create an account with our cloud, you'll have a username and password, and then you can actually use those same credentials to go into to log in on retrotec.com to your portal, and you can have all of your test information there, have all of your calibration information there. You can see, when equipment needs to be recalibrated and things like that. Basically, every aspect about any test you've done in our cloud, or any information about your equipment can be found there.
Awesome.
Yeah.
Larry was asking if we're going to do duct leakage to outdoors in our cloud.
So technically you can, and you would just do it the same way. But you would have to do it in a way to where you don't seek zero. You would have the two manometers tied together, referencing the outside, and you would have to do the test that way. From some internal conversations that we've had, as we update our cloud later this year, it's looking like we're going to add some more options in there for running tests in our cloud, so you have that option to seek zero. So yeah, there's two ways you can run a duct leakage to the outside test. What we're going to do is here in the next few minutes, we're going to do it to where you have your blower door that's independent from the duct tester, depressurizing the house to negative 25 pascals, and then you just have the duct tester seek 0 to neutralize the pressure between the duct system and the house, and that gives you your duct leakage to the outside. Or what you can do, you can tether those two manometers together with you have a tubing T connector to reference to the outside, and then you can have both pieces of equipment seek 25 pascals. And sometimes that can take a lot you may not have in your bag. So for example, if the duct tester is far away from the blower door in the house, you're going to need more tubing to make that connection happen. So that's why most people just go ahead and just do the seek to 0. But you can do it that way. But we're not going to demo that today just for time. We're just going to show how to do a duct leakage to the outside test manually with seeking 0.
Can the app take a picture of the gauge screen for presentation?
No, and I'm not sure why you would want to. Having this report kind of defeats the purpose of needing to do that. I know a lot of providers like to see that if you're a HERS rater, seeing that picture of the gauge, but this is a report straight from the manufacturer's software. So all that information is already in there. So adding a picture of the gauge is a little redundant at that point.
Actually, I think he probably means from the gauge remote app is what I'm gonna guess.
Oh, like take a screenshot?
Yeah, so that would probably be the answer there.
Yeah.
Screenshot through the app through your device.
Oh, definitely. Yeah. Yeah, we have customers that do that all the time. Like if you're writing up your own custom report, yeah, you can absolutely take a screenshot of your reading and then do whatever you want to with it. It's like taking a screenshot of anything else.
It might be a good feature request. We can see if that's possible to add down the road.
Yeah.
Let me see. Sorry, there's one other one here. Question if they could add their company logo to an rCloud report.
Yeah, that's a feature that's coming soon.
Okay, awesome. And I think we have covered all the questions.
Cool. Well, I'm going to put gauge remote back up, and I am going to grab you guys here and kind of show you what we have set up here. This is a test chamber that I built last year, and we can use it to simulate basically anything we want. It can be an HVAC system, it can be a house, it can be a commercial building, whatever. So there's actually a chamber above. If you see the Retrotec logo there in the middle, that's actually an isolated chamber. We can use it as an attic space, whether if it's encapsulated or vented. There's some panels on the side that we can take on or put on and take off. And we can use it as a duct system, and that's what we're doing here. So I'm going to see if I can get you guys closer just so you can kind of get an idea of what's going on. You can see that we have this other duct tester here set up. We're saying that this is the return side, and behind there, you see some more tape, and that's going to serve as our supply side. And you see our blue tube coming down from there. So this chamber above is going to be our duct system that we're going to test. And then we have our blower door set up there for our duct leakage to the outside portion. So let me get this kind of set up for you, get things on so I can see what I'm doing. So since this, let's put it on this side so you can see what's going on there. I'm going to use the same gauge that I just used for the other test, and it's going to be inside the chamber, but it's still going to be tied to this iPad so you guys can see the readings there. So I'm just going to pop that off. So when we do this kind of test, we'll set up the blower door just like we do if we were just going to do a regular blower door test. The only difference is instead of seeking 50 pascals of pressure, we're going to have it seek 25. And the important thing to remember is we want the blower door and the duct tester facing in the same direction. So if we're actually pressurizing on this system here. So if I'm pressurizing with the blower door, then I want to be pressurizing with the duct tester as well. What we're doing here is kind of called pressure matching. And by doing this, by seeking zero, we're just neutralizing the pressure between that duct system and the interior space. That way, the only reading that's left over is any duct leakage from the outside of the building. So by neutralizing that space, it's going to cancel out any interior leakage. So if you're familiar with blower door testing, like guarded testing for apartments or townhouses, it's a similar thing. In that case, you're neutralizing the pressure between a common wall, but here we're just neutralizing pressure between the duct system and the interior space. So what I usually want to do is go ahead and get the blower door running first. And the reason that I want to do that is because it's a more powerful fan. Once I get that up and running to 25, then that fan isn't going to be overpowered by the blower door. Sometimes if you run that fan first, that fan can overpower it, and sometimes it can just take a little while for the two of them to reach that equilibrium. So we'll go ahead and pop this on here. I don't care what the flow is. All I want to do is get the space to positive 25 in this case. And I'm pressurizing this time just so you guys can see the inlet sides of the fan in case I need to change the range or anything like that. So I've make sure I've got my doors shut. Obviously, in this case, you can't leave a door or a window open or the blower door will not get the pressure. So we'll go ahead and seek 25 pascals. And one thing that I'm going to do here, in the top right-hand corner, here I can show you here. There's actually, you can see like a 0% speed there. So if this were the gauge that we're running, we would see a percent speed that fan was running. Since I'm actually going to go into the chamber here and do this manually, I don't want the fan to ramp up when I open the door to go in. So I'm just going to look at the percent speed that it's running. So it's running at 25% speed. So I'm going to hit stop. And instead of saying set pressure, I'm going to say set speed and hit 25. And it's going to take me right back to where I was. But now, once I open this door to go in, it's not going to ramp up and scare somebody. So I'm going to go ahead and hop in here. Shut the door behind me. You guys should still be able to hear me okay. And I'm going to hook this manometer up the exact same way that I did last time, using our color coding protocol. One thing that I'm going to do a little different this time is I'm not going to use the control from the gauge. I'm going to run this manually with the dial on the side of the fan. And I'm mainly doing that because I can get there faster. Sometimes when you let the gauge do it automatically, it can take it a little while to get there. It'll get there eventually, but it does take a little longer when you do it a leakage to the outside test like this. So you can see on my screen there, now that I have the manometer hooked up, you can see that negative 3.6 pascals. That's what we want to cancel out. So we want to get that down to 0. So I'm going to cut the fan on. And just work this control dial until I get it down to 0. Now you notice that when I got to 0, my flow reading went away. There was just 2 dashes there. So what that's telling me is I need to go down a range. The fan is too open. It's not generating enough pressure inside the fan shell to give me a reading. So, well, I did have it on 74 there on the gauge, didn't I? My bad. We'll try that again, but I think it's still going to be a little too open. That's why it's important to have the right setting selected, or you'll get some wonky numbers. Yeah, so even when we still got the 0 there, it was too open. So on the gauge, I'm going to go and change. The next one down is 47. And we're also on the 300 selection instead of 340, which isn't going to make too big of a difference. But we do know that we need to go down. So 74 to 47. We've got the 340 now selected. We've got the 47 range selected. And we'll try this again. And we're getting closer to 0. We still have our flow in CFM. We'll give it a little more juice to see if we can get that 0.4 to go away. There we go. So about 31 CFM total. And if I wanted to go in and change that to CFM per 100 square feet, there we go. So it's going to be a much lower number every time. So if you recall, we're canceling out a good chunk of the leakage here. Any leakage coming in from that duct system to the interior space is not included in this result. So it's always going to be a lower number compared to a total leakage test, which is why it told me that I needed to go down a size. So a lot of times when we do this duct leakage to the outside test, that's going to happen. You're just going to need to go down a range size in order to generate enough pressure inside the fan to get a reading here. So it looks like a little over 3%, 3.15% leakage to the outside is what we're getting here.
So Sam,
yeah,
you're just you're following that rule of thumb where if you can't get to your target pressure and the fan's maxed out, you go up a range. But if you can get to your target pressure and you're getting no flow result, you go down a range. Even though we're setting to 0, it's that same rule of thumb.
Right. So yeah, if it were the other way around, if I were, let's see here. Okay. That's right. Cut the gauge off, so it disconnected. Yeah, so if it were the other way around, say I couldn't get to 0, or if I'm doing a total leakage test, if I couldn't get to 25, then that means I'm going to need to open something up. And if I have that fan open and I can't get to 25, something's seriously wrong. I either missed something. A lot of times this happens. Sometimes there's some supplies in some sneaky spots. So you have to go back around the house and make sure you didn't miss a supply or a return somewhere. 9 times out of 10, that's what it is. You missed one. Or, there might be a duct disconnected somewhere. So, if you can't get to 25 with the fan running open, there's either a mistake that was made or there's a serious issue somewhere.
It can be confusing when you're doing the duct leakage outside because you want 0 on the gauge if you're not referencing outside with the depth tester. So it's if you start or before you start the fan, you can look at channel A and see where you're at, and then just slowly ramp up the fan like Sam was doing and see that number drop, and that'll kind of help you keep it straight. Because that is something that is pretty confusing. I get questions on that a lot.
Sure. I got a question emailed to me last night from someone that I wanted to make sure I covered today is zone dampers. If you're testing a zoned system, you want to make sure all of those zone dampers are opened up. If not, there's part of the duct system that's isolated from the rest of it that you're not including in that duct test. And what can happen is when you have that blue reference tube measuring your duct pressure, if it's in one of those branches or one of those sections that's isolated by that zone damper, it's not going to feel any of the effects from the duct tester fan. So it's going to look like there's a massive hole somewhere because you're never going to get the pressure because your probe's not feeling it. So it's always important to make sure any zone dampers are all the way open. You know, it's kind of like when we do a blower door test, we want to make sure all the interior doors are open because we don't want to cancel out any rooms in the house. We want to have an equal pressure throughout the house. Same thing with duct testing. We want to have an equal 25 Pascal pressure all the way through that. So we have to have all those zone dampers open in order to do that.
Right. Another reason it's critical is to take the filter out as well. You'll run into that same issue.
Yep.
We had a question here. Do you need to do a baseline on the blower door before you start it when you're doing the duct leakage downside?
Yeah, you should. Yeah, and that's something I should have covered. I kind of jumped into it to try to save time, but yeah, you should do that. And it's even more important here because it's even lower pressure that we're seeking. So any wind outside is going to have a larger effect. So yeah, good call. You do want to do a baseline reading on your blower door.
And someone was asking if your test enclosure that you built here, if the two zones are connected, you're running the fan on the right side and the duct tester was on the left. There is connection between those two zones.
Yeah, so there's a, let's see if I can grab the camera here. See if I can get you to look in there. What you see behind that flex is, well, I've got two double doors in here. So I can have this set up to be like 2 apartment units if we wanted to do guarded testing, but I've got one of these doors open. So the entire space is connected. So yeah, they're not separated from each other. They're, you know, one of those doors is wide open.
Awesome. Okay, I think that was it for questions.
Yeah, if you were at the ResNet conference, we had, Lee and I did a presentation on multifamily buildings where we actually walked through that using the same chamber with that double door serving as that common wall. And that's something that we'll have uploaded to our YouTube channel pretty soon as well. But yeah, I think we've answered all the questions pretty much, Lee, unless there's a few more that snuck in the box.
Someone was asking about how to connect the gauge remote to your gauge. I don't know if we have time to kind of go over that process and how you can do that with Wi-Fi Create on the manometer.
Yeah, we can. Yeah, sure, we can do that. Let me grab the gauge here. So what you're going to do is you'll go into your settings. You'll go to the next page and you'll go to network. There's Wi-Fi join, Wi-Fi create. That's what you're going to do if you're going to pair the device to the gauge. So if I wanted to go in here, go to my Wi-Fi settings here, I see my DM32 right there with the serial number, and now it's connecting to it, and there's a check mark. So now my device is paired. Go to find gauges. Let me close it out actually, since I was just using it with Wi-Fi join. There we go. Connect, and there it is. That's how you use Wi-Fi create. There's another option called Wi-Fi join. So if I go into my settings here and hit network and go to Wi-Fi join, you can do wired, you can disable it. What it does is it does it in the other way around. it allows the gauge to pair with the hotspot coming off of the device. Yeah, see, I kicked it out. And we've actually found that the Wi-Fi join is actually a stronger connection there. It's more stable. And in order to do that, you have to know what the username and password is for the hotspot on the device. And then you'll plug this into your PC. You'll pull up the DM32 configurator that you can download from our website. And then there's a tab for Wi-Fi. You just enter the network name and the password, and then you save it to the gauge. And then once you have the hotspot open on this, it'll pair with it automatically. And that's what I like to use. It's for me, it's been more reliable in the field. So there's 2 ways you can do it.
Okay, cool. I think that is it. Oh, is our new smoker device out yet?
No, not yet. Unfortunately, there's some more pressing projects that we're having to get through first, but it is coming. We are expecting it this year. I know a lot of people have been asking about it, and it is going to be really cool. It's going to produce, more smoke than the Tiny S does. So it'll be really good for smoking entire duct systems, and you'll be able to do it wirelessly with Bluetooth. So you can actually set the device inside of a duct system and discharge it with your phone remotely, and slightly pressurize the system with the fan and see smoke come out. So you can attach it to an extension pole to get up to high, hard to reach spaces. So trust me, I'm just as antsy as you guys are about it, but it is coming, and it'll be worth the wait. And
Okay.
someone gave me a call earlier today asking a similar question about smoking. You can use a smoke machine to smoke the duct system, but do not run smoke through the inlet side of the fan to pump it in there. Detach the fan from the flex, apply your smoke into the flex, and then push that smoke through with the fan. You don't want to run it through. The only fan you can do that with is our commercial duct tester, because it has a sealed motor. The residential duct testers do not. You can end up damaging those components over time. So if you're going to smoke a duct system like that, push it with the fan. Don't pull it through.
Excellent point.
Well, I guess we can wrap it up there. If you have any questions, you can get to Lee or Tim at support@retrotec.com. If you have questions for me, you're welcome to shoot me an email shoot an email to me, sam@retrotec.com. I'm happy to help in any way that I can. And appreciate all of you joining us. We are recording this, and we're going to put it on our YouTube channel later on. And keep an eye out for the next webinar that we're going to do. We'll likely do a full blower door demo, similar to what we did today, to kind of dive into some of that stuff there. And we'll announce that here in the near future. So if nothing else, Lee, thanks for hopping on today and helping out with questions. And we'll see all of you again next time.
Thanks, everyone.
Yeah, thank you.